So absolute convergence has to do with series that are absolute values of maybe another series. So an absolute series is going to be a series where all of the terms are non-negative. And we can get an absolute series very easily just by taking the absolute value of any series. If we take the absolute value of any series, we're going to get an absolute series. So we have this formula, or I'm sorry, not formula, but theorem. And this theorem says that if the series absolute value of a sub n, so this absolute value series converges, then we use this term here. The series itself converges absolutely. So what this means is if we have any series, and I'm gonna give you an example because I think this is easier to understand with an example. Let's say we have the series 1 minus 1/2 plus 1/4 minus 1/8. You guys know what series this is? It's a geometric series, right?
Yeah.
It's a geometric series with r is equal to what? Negative 1/2. So is this series here going to converge or diverge? It's going to converge, right? Now we know it converges because it's a geometric series and the common ratio is, the absolute value of the common ratio is less than 1. The absolute series that is related to this, the absolute series for this particular series, would just be this. It would just be the same series, but every term is positive. And so on, right? Well, this is a geometric series with r equals 1/2. Does this absolute series right here converge? Yes. This converges because why? Absolute value of the common ratio is less than 1. All right, so we know this series converges. This series right here converges absolutely. I'm sorry, this one right here. It converges absolutely because the absolute value of the series also converges. So if we take the positive of every term and add them together, it still converges. So we use this term converges absolutely. It's important because of this theorem right here, that absolute convergence implies convergence. So if a series, an absolute series converges, then the series itself converges. So what this is saying is if we take the absolute value of every term in the series and it converges, then we know that any series involving those terms, whether those terms are positive or negative, are also going to converge. And the reason is, worst case scenario, the biggest that these numbers can add up to, we know that's a finite limit. Worst case scenario here is they're all positive and that's the biggest sum we could get. Or if they're all negative, then that's the largest negative sum we could get, if every term here is negative. So if some of the terms are positive and some of the terms are negative in an absolute series that converges, then that series is also going to converge. So what this theorem right here allows us to do is it allows us to use theorems like the direct comparison test, where the direct comparison test only works if all the terms are positive. So we look at, rather than a series like this, where some terms could be positive and some terms could be negative, we just look at the absolute series, and if this absolute series converges, then we know that the series itself would converge also.